We literally take 30 million electrical measurements per second. So we just measure the voltage. We don't measure current. We're just plugged into one outlet. So we take 30 million electrical measurements per second in the device, and we use AI on the device itself. So everybody's talking about AI these days. This is an incredible application of AI. So we run AI on the device itself, and then it's connected. So we stream data to the cloud.
This is episode 92 of the Fire Protection Podcast, powered by Inspect Point. I want to welcome my guest, Bob Marshall from Whisker Labs, or their product called Ting, onto the podcast today to discuss this great device that I discovered a couple years ago. It was in essentially a yellow bag saying the future of fire safety. Open it up. My insurance company provided it for our residential house for electrical safety. So I've been super into it since then. I've put it out in a variety of presentations with IoT and kind of the future of fire protection. So glad to have Bob on and his experience with grabbing data from different networks and his experience and second company that he started here with Ting. So we get into it. We do some screen sharing. So there's a lot of cool data of what they're doing at Ting and what they're providing, helping NFPA and UL with, as well as a lot of the utility and insurance companies out there. So hope you enjoy, and on to the podcast. Thanks. Bob, what's happening? How you doing today?
Hey, Drew, it's great to be here, man.
Round two. The recording unfortunately stopped, but we're back. I started chatting with Bob. I've been impressed with the company Ting for a while. I wanted to get him on the podcast. And a couple years ago, a year and a half ago, got an email from my insurance provider for homeowners insurance. And it was a yellow bag saying the future of fire safety. So got really intrigued with it. Signed up for it. It was really cool. And it was kind of in the realm of what we do at Inspect Point, but just in fire protection, an IoT device to measure electrical current in the house. And I've kind of been obsessed with it, talked about it in presentations since. So Bob, thanks for coming on today.
Well, first, it's great to have you as a customer, and I'm glad you got it from one of our insurance partners. We work with about 35 insurance partners now, and that's growing every day, that are basically giving away our product that we'll talk about here for free because we prevent more fires than the cost. But our insurance partners are investing in their customer safety, and it's kind of a whole new movement in the insurance sector to try to predict and prevent losses versus just dealing with catastrophic losses after the fact. So yeah, I'm glad you heard about it from one of our partners, and great to have you as a Ting customer.
Yeah, you have quite the cool story getting into what you're doing now, and I know we chatted the other day, but tell the audience who Bob Marshall is.
Yeah, look, I am an engineer by degree and technologist, and I guess an entrepreneur. This is Whisker Labs is actually the company behind Ting, the product that we'll talk about. But it's the second company that I've had the good fortune to co-found, and the origin story is pretty unique here. For sure. My sister-in-law's home unfortunately experienced a devastating electrical fire several years ago. And they lost a pet, they lost everything. It was just a catastrophic fire. And at that point, I'm an engineer and a technologist, but I didn't know anything about electrical fires in general. But you look up NFPA data, and there's roughly 50,000 of these things every year. That's one every 10 minutes in the U.S. And, they're often not, some of the most devastating fires that impact homes and families because there's always electricity being used. These fires can ignite when you're asleep. They can ignite when you're away. And that's why they're often devastating losses. So, we had some technology at the prior company. And, after kind of studying this a little bit, I challenged our engineering team, our chief scientist, and said, why can't we come up with a product to detect the arcing? It's usually electrical arcing that causes electrical fires, not 100% of them, but, so it's loose connections and damaged wires that, they start out often very small, tiny little scintillations and micro arcs. Yep. They once you get that first arc, they can't repair themselves unless you intervene and fix them. So they develop over time. So I challenged our team to So why can't we come up with a product to prevent these things? And, it turned out to be much harder than we thought when we set out to do it, despite our technology and background that we had. But ultimately, we came up with a product called Ting. So, yeah.
Who did you create the word Ting? We didn't talk about that the other day, but where does that come from?
No, after we, ultimately we, this is a classic kind of startup scenario. We, and I'll hold the product up. You got a lot of you probably have it, but it is just a super smart plug. And you only need one per home. We can talk about how it works later, but when we finally realized that we could develop a product, we were, just sitting around the office one evening, probably over some beer and wine or whatever with a few people and looking for, what can we call this thing? And we wanted something that would be short and memorable and kind of have give you that perception that it when it notifies you, it's important. So it's like a ting, so it's, so we just came up with it one evening and looked around and figured out that we could, we couldn't get ting.com, but we have tingfire.com, which is the URL for the product. So that's how that got started.
It's interesting because, you hear another IoT device, right? Ring. Everybody's got that on their home or Google, whatever. So it's kind of right in line with that. So, it's exciting to see it. And, recently I've had to essentially monitor our electric because of, storms and everything coming by. So it doesn't just detect fire, it detects outages too, right?
Yeah. I mean, so it's Ting itself is a very sophisticated sensor. So, we can talk about, some of the details behind that, but, we literally take 30 million electrical measurements per second. So we just measure the voltage. We don't measure current. We're just plugged into one outlet. So we take 30 million electrical measurements per second in the device, and we use AI on the device itself. So everybody's talking about AI these days. This is an incredible application of AI. So we run AI on the device itself, and then it's connected. So we stream data to the cloud, and we actually do additional AI in the cloud. But the primary thing that Ting does is detect arcing. Mm-hmm. So that's the cause of most electrical fires. So it's primary purpose is to detect that arcing, and we detect it early, where we have time to notify the homeowner, engage the homeowner, and find and fix it before it starts a fire in most cases. But it also, so that it's a very sophisticated electrical sensor. So we monitor power outages, we monitor power surges. We monitor power brownouts. We monitor total harmonic distortion, power quality kind of things for every home that Ting is in. And then the network of sensors, we'll talk about that too. The network monitors the U.S. utility grid. So it's a sophisticated IoT sensor network, starting with a focus on just helping protect families and homes from electrical fires, and then. We've learned incredible things over the years on what we're finding in homes, what we're finding on the grid. So, it's been an adventure for sure.
Yeah, I had it in, obviously installed. It's been for well over a year now. And we had a recent issue with a squirrel getting in over the winter and chewed some wires and, I actually ended up going back in the app, and it did pop up that something was going on. It also flipped the breaker too, but it alerted me. I didn't know back then, but because the breaker went off. But
I mean, we hear about squirrels, and we often detect wires that are arcing in an attic or something because squirrels have kind of set up shop in the. And set up a home in the attic. The other thing that we hear about very often is squirrels tend to love chewing the neutral wire up from the utility to your meter. So we're routinely notifying utilities that the neutral wire, and that's a very dangerous situation too. Sure. So if you have no neutral, you're getting power surges and brownouts, and there's stray current flowing somewhere in the house, which is very dangerous. So squirrels. It's amazing how much they like wires, right?
I talked to my squirrel guy, and he's like, this is just what they like. They get up in the eaves, and good luck.
Yeah.
Yeah. So yeah, obviously experience with that. And I guess what type of AI is on you said there's AI in the device and then you have it in the cloud. Is it looking at like different signatures? I guess how are you utilizing that?
Yeah, and this is the power of AI and data today. So again, we essentially only monitor voltage. So voltage in U.S. homes is nominally 120 volts, but when you measure it 30 million times per second and do very sophisticated signal processing on the device, we're looking for very, very, very tiny deviations in that voltage that are caused by electrical arcing. So when you think about, if you just think about a home and an IoT device at 30 million measurements per second, we could never send all that data to the cloud. You don't even have enough bandwidth. You wouldn't be able to do anything at home on your internet connection. So the AI on the device actually is been trained to specifically look for signals that are indicative of electrical arcing. And then we have to compress the data down and send back a very small fraction of the 30 million.
Wow.
And we compress that down to roughly 30,000 data points per second. And 30,000 data points per second. So the AI, that's what the AI does on the device, is figure out what data, when it thinks there's a potential problem in the home, what data do I need to send back to the mothership, the cloud, to do additional analysis. And so we compress it from 30 million down to 30,000. And then we stream that data to the cloud, and then we turn it into an image. Mm-hmm. So it's a very unique approach. So I can probably even share the screen.
Show me the kind of
seeing it. I know everybody's talking about AI, and it's just. Yeah, and I certainly was not an AI expert. I am an engineer, but it's just incredible what the AI can do. And you're seeing that now,
I see that
right?
now. Yeah.
So and obviously there's lots of uses of AI, but this is a case where we're using AI solely for the purpose of detecting electrical problems, so this is an example of Ting's AI in the cloud. So, this is from one single sensor, and we've taken 30 million measurements per second. We've compressed it down to 30,000. And this image that you're seeing on the screen is actually, one utility cycle from left to right. So it's, 1/60th of a second from left to right. And then every pixel row that you see going past is another 60th of a second. So this is 30,000 points per second streaming past, and you can see the high resolution data. And it turns out that arcing has you see some diagonal lines there. That certainly is not arcing. What we find with arcing is, it's got a very unique fingerprint associated with it. So the AI in the cloud uses image recognition AI.
Oh,
so you think about, so what does that really mean? You don't really realize it, but if you go onto your phone, right, and look at all your photos and you just search on dog, it's incredible, right? Yeah. That phone will find every photo in your whole album that has a dog in it. And it's using image recognition AI, right? So, and if you're driving a self-driving car or riding in a Waymo or something like that, what is it doing? It's got cameras everywhere, and it's literally in real time analyzing the imagery to detect lights and traffic signals and cars and people and you name it, right? And it's incredibly powerful. So that's what we do. So we have a lab in Maryland at our headquarters, and we train the model to specifically detect arcing, essentially. And when we started, we had no idea. I'm showing you, we've done this now 26,000 times where, Ting has identified a problem in a customer home. And we've notified the customer. Our fire safety team, and I can talk about them in a minute, but because it's not just technology, it's not just a piece of hardware. We actually have to work with the homeowner, like person to person, right? It's a people.
Yep.
We have to work with the homeowner to identify the source of the arcing. And when we started, we didn't know that. We just thought, geez, we're pretty confident we can detect arcing, but it turns out that, like, if you see an extension cord or an outlet or a breaker, the arcing signatures from each of those things are different. They all have a unique electrical fingerprint. So now, over time, we've developed what we call a hazard reference library. It's an image library. And I want to be clear too. Obviously, when I say image, some people are like, "Oh my God, does Ting have a camera?" No, Ting does not have a camera. It does not have a microphone. We're taking electrical data and turning it into an image, and then using image recognition. But we now have pretty much when we detect arcing in a customer's home, we have a very good idea of what the source is. It could be a water heater, it could be a power strip like you see on the screen there. So. Anyway, I'll pause there because I've been talking too much. But I get started talking about data, then I get excited.
It's great. Yeah, I mean, 26,000. Saved. That's incredible for the time you guys have been doing this and getting.
Yeah, it's 30 times a day. So wow. 30 times a day now. So our fire safety team is working with. I mean, I think we probably have 2,000 active cases today.
Wow.
Means, we have roughly 1.3 million homes now, and on the order of 2,000 homes, we know that there's electrical arcing going on in the home. We've notified the homeowner. So our fire safety team, I think we have 70 fire safety people. They're engineers, they're electricians. They've been trained on how homes are wired, how the technology works, how the data looks, and they're trained on how to communicate with homeowners to find and fix the problem, then work with electricians. So this, the video that you're seeing, on the screen is, from an electrician visit. We actually pay for the electrician too. So, you're a Ting customer. If we detected a problem in your home, like we did in this customer's home, we would typically work with you we would work with the homeowner to, we're going to know it's associated with an outlet. But we don't know what circuit it's on. Ting could be installed in an upstairs bedroom, which it was in this case. And then this is like in a downstairs basement that, I think the uncle had done some DIY electrical work, which we not too often. And, so we had the homeowner turn off one circuit at a time until they turned off the circuit that had the arcing on it. And then we see it stop right away, right? Wow. We get the real-time data. So our team knows. And then we just have the homeowner leave that circuit off and schedule the electrician. Yep. And this is the video of the electrician. So, so that's what we do every day. And, we'll pay, we probably have 25 electrician visits across the country today that we're paying for. We cover up to $1,000 of that, wow. Which almost always covers the cost of it for the homeowner. But, it just wouldn't be, it would never work if we just, told you, well, you're different. You're a fire safety. Okay. If we told you had arcing in your home, you might be able to find it. But the average homeowner, if we just told them that they have an electrical fire hazard, they would have no idea what to do. They'd never find it, right? So we actually we've got to communicate clearly and calmly and precisely to the customer, schedule the electrician if we need it. Sometimes you don't need an electrician, right? If it's a power strip, we know it's a power strip. You unplug the power strip, the arcing stops. We often see a little char mark on it, and then just tell them to discard the power strip, and then the problem solved, no electrician needed. So
yeah. Have you seen certain times a year that are, you probably have a lot of data at this point. Is there certain times of the year that are more, is it like Christmas time and Christmas lights, or is it?
100%. And this is a great, Thanksgiving, the day after Thanksgiving, we know there's going to be a surge in cases the day after Thanksgiving. Because what's everybody do? You start pulling out the holiday lights, and they've been crumpled up in the attic or in the closet somewhere, and they're probably 20 years old. And lo and behold, you plug them in, and then you plug them in, you got too many of them plugged in, you're overloading the power strip, you got a loose connection somewhere. So that the winter is definitely, then it gets cold and people start plugging in space heaters. right? And so, I mean, they're, what we know for sure based on our data is, outlets are the most dangerous thing we find in general. I mean, we find arcing, they're all dangerous. Everything that we detect could cause a fire. But you start overloading an outlet, and it's behind the outlet cover, it's in the wall, you can't see it. I mean, so we, and you put too much load on it. If there's just a tiny loose connection, right? All it takes is one arc, that we know the physics of it now very clearly. I mean, so if you've got, a copper to copper connection that, is slightly loose, and you put enough load on it and it creates one tiny little micro arc, then it oxidizes the copper, and then it creates a path for another one, and then another one, and then another one. And then, that can happen over weeks and months of time. But, once you get electrical arcing, it can't fix itself.
Without repair.
But the data, I mean, I want to come back to the data, because I think, I know you have I've watched some of your awesome podcasts, and, you have a lot of NFPA folks and people in the community. And, I think one of the things that I'm, really want people to know is that we've accumulated incredible data on the problems, because we're, when you think about it, I mean, we're detecting the earliest stages of what would be future electrical fires. Mm-hmm. And we find them and we fix them, but then we document it all, right? So every one of those cases is now a piece of data that can help researchers at NFPA and UL and other organizations understand, because we know, where in the country, are there particular areas of the country that are worse than others? Are there, we know age of home has a big factor, but size of home, value of home, where in the home, what percentage are associated with the electrical panel, old electrical panels, what percentage are associated with switches and outlets, what percentage are associated with power strips or heating blankets, right? Heating blankets and things like that. So, we've got incredible data that we want to, support the entire fire safety, fire protection community because it ultimately can inform codes in the future and things to prevent them from ever even getting to Ting.
Yeah.
Right?
Yeah. And I know, NFPA and UL have been after that, right? They need the data to make decisions about the new codes. And they're, I think they've struggled in the past of how to obtain the data, but there's projects that they're starting, and obviously you're working with them directly to work on the National Electrical Code and other things. So I think that's important to kind of push the codes in the future, right?
Yeah, and we're not doing too much yet. I think we would like to do more. I mean, because it's, when you look at it, I think it's a problem that the whole community deals with, right? I mean, we try to look at the NFIRS data, and then the new system that's being developed, and obviously there's some value there, but I think everybody that we talk to, it's pretty challenged. I mean, it's hit and miss, it's geographic dependent, and it's tough to. And then after devastating fires, it's hard for fire marshals and firefighters, fire departments to make a accurate determination of what the root cause, right? I mean. Sometimes they're reluctant to do so because it's just they can't prove it, and there's litigation and the whole thing.
Well, if you have the data,
it just makes the data kind of noisy.
Yep.
And I think in our case, it's we've got a very uniform set of data that, again, hopefully it can just help the community at large. So,
can the device detect thermal runaway from a lithium-ion battery, or is I don't know how? I'm pretty.
That's a great question.
Yeah.
And the answer today is no.
Okay.
I will say that we've run some tests, and that's one of the things I'd like to work on with, we have a lab where we can generate all kinds of arcing, every kind of arcing you can imagine in our lab. But one thing we can't do in our lab is have a lithium-ion battery catch fire, because it's like super dangerous.
Oh, yeah.
In our lab. But UL and some other organizations, ATF, they can do that. So I think it's possible today. So the short answer is no today. Obviously the battery, if the battery is not connected, if it's not charging, then we have no chance. But if it is charging, it is connected, but it's on the other side of a transformer. So, is the breakdown of the battery going to create a signal that gets out through the transformer and onto the where it's plugged in? I think there's a decent chance that there may be something for us to see. It's going to be hard. We know that, but Ting is a super sophisticated sensor. So we would love to, figure that out if we ever could, because obviously it's a big.
It's since I've been doing the podcast, that's the number one top few issue, right? Wildfires are tough to, I know you guys have some stuff you're doing with wildfires, but lithium ion batteries is like, and it's not all, I think overall, I think the batteries are great, but it's when you get an unapproved charger and, all the stuff that was, working with the, New York City and the FDNY, they've gotten those fires under control in New York City, but they're still happening, and it's, I think if you had a sensor to detect that, they're frightening. You can't stop them, and there's no way to stop them. So the first thing is detection. So if we can figure out detection, I think it doesn't solve the problem, but it puts a big dent in it.
I think what we know in general is that electrical hazards that result in electrical fires and you can put lithium ion batteries in the same category, is that for the most part, they go through what's called an incipient stage. They begin to break down, and it's pretty small. So you have some time. If you can detect it early, you have time to, address the problem before it gets out of control. That's not always the case. I mean, so people ask, we say we prevent 80% of fires, which we know we do. What's the 20% there? Because Ting can't prevent all electrical fires. I mean, one of the things we can't prevent is an immediate and catastrophic failure. So, if the example that I share, and this would apply to batteries too, I mean, is, if you hang a picture on a wall and you nail the hanger in and you pierce the wire on the stud just right, it probably starts arcing right away. We may detect that, but if it's severe arcing and you walk out of the house, I mean, we typically monitor for many hours and days before we notify the homeowner. So if there's an immediate and catastrophic failure, that's not something we typically can prevent. Because we can't turn off, we're not a circuit breaker, so we can't turn off the power, right? So that's one thing. Same thing with batteries, right? If there's an immediate and catastrophic failure, even the monitoring wouldn't get it. But I mean, we do detect problems with chargers all the time. So, so not the battery, but, obviously if you've got, your tools out in the garage and your charger's plugged into an outlet, and it may not be the battery, it may be that outlet that's become loose in the garage and your charger's plugged into it. So, that obviously is, if there's a problem with the outlet, that's a hazard. And then we've had, not as many as I thought, but there's definitely like some EV, Tesla saves that we have where, lo and behold, a customer had their, I know at least a couple, the customer had their Tesla plugged in through an extension cord, which is just not obviously a great idea. So you overload that, create some heat, create some thermal imbalance and cycling, and then next thing you know, you got a loose connection somewhere that's arcing away. So we've prevented some fires more on the charging side than the battery side.
Well, I think that the charging side, and funny enough, you bring that up. So one of the upcoming guests I have is one of my mentors. He's the CEO of Viking, which is a big fire sprinkler manufacturer, right? He's CEO of the company. He's doing a big renovation on his house, and he had a bad charger on one of his. I mean, I got to talk to him about it, but it'll be on an upcoming podcast. But he had a bad charger on his DeWalt or drill or whatever, and they got lucky. They got really lucky to get out of the house. But again, it was under construction, so you might not have a Ting at the time, but if you're detecting chargers, I think that's a lot of the problem is the chargers.
Yeah, I mean it's chargers and just the connections, right? I mean, depending on what you're charging, I think what we know and what the data shows when we look at kind of what we're monitoring on the grid is that, we're plugging more things in, right? There's more things charging. There's more battery. There's more solar. There's more EVs. The grid with data centers and other growth and demand, it's becoming more complex. Our data shows, unequivocally that the grid is becoming more stressed. And home wiring is becoming more stressed. So, I think it's kind of a perfect storm of higher threats for people today. And, I'm hopeful that our data, ultimately will help make the grid more resilient too, because the catastrophic grid failures, whether it's wildfire ignitions or, hurricanes and, the Texas meltdown from a couple of years ago, it's just, a grid failure can wreak havoc for society, and we've got to kind of do what we can to make the grid more resilient. Yeah. So the way to think about it is that, we've obviously got a super sophisticated electrical sensor individually with Ting. So each Ting that is installed monitors the wiring in the home. Yep. It also monitors the quality of the power being delivered from the utility. So, we see power quality problems from the transformer to the home very clearly and dangerous things. But importantly, the network of Tings, which is 1.3 million homes now, and we're adding 50,000 new Tings per month across the U.S. So the network is growing very, very rapidly. And the network of Tings now takes 30 trillion measurements per second of the U.S. utility grid. So, we can detect, problems on the grid everywhere from, the transformers serving homes and buildings to the distribution lines, upstream to the transmission lines, all the way to generation.
Speaking of electrical grids, the good old fun Comcast, which I have here, that gave us a little outage. So, Bob, you're explaining kind of some of the these big storms that are happening and how Ting can help with that.
Yeah. So I'll show an example here, Drew, of Hurricane Helene. This was a year and a half ago or so. So what you're looking at here is kind of the power of an IoT network, right? So each white dot is a Ting sensor installed in a community, in a home. And when they're powered, they're white. And when they lose power, they're red. And each of the blue flashes of light that you see is a fault on the utility grid. So what is a fault? anytime a tree limb touches a wire or two wires touch each other or a pole comes down or something, it typically creates a big arc and a very clear signal in our data. And then there's often a power outage associated with it. So, this kind of data, there's no source for real-time neighborhood level power outage data across the U.S. So we're working hard to provide this data to first responders, to emergency operations centers, police, fire. If they're going into communities after natural disasters, it's really important from a communications and power perspective to understand what's going on. What are the people dealing with? So this is the kind of the power of the data. That comes off of the Ting network, and even providing this to utilities because, the Winter Storm Fern, which is closer, just a few weeks ago, right? This is you look starting in Northeast Texas, then through Louisiana, up through Mississippi and into Nashville, right? Over 1 million homes in the U.S. lost power. And, often many of them were out for 10 days or more in Nashville and Oxford, Mississippi, and in places like that. So, so this is the kind of data that's available for the first responder communities. And, and this is just going to get better and better, right? There's literally, I think 95% of U.S. homes have a Ting within 1 mile. So effectively every neighborhood has a Ting sensor in it. And, we monitor all that data from every one of those white dots. It's like 10 gigabytes of data per second coming into our cloud, right? And, our system monitors everything in real time. And our objective is to just help utilities, help first responders and help, make the grid more resilient because it really does become a safety issue.
Sure.
for communities. And in fact, I hate to talk about, when we lose a Ting home, but we had a fire in a Ting home after Hurricane Helene that I just showed a second ago. What happened was the wind had basically wiped out the neutral serving the home. They lost power. The homeowner was away for weeks, and there's near Asheville, North Carolina. And this is an immediate and catastrophic failure kind of thing. As soon as they turned power back on, there was no neutral. Ting came back online. We saw it, and it was just horrible. I mean, it was just really, really dangerous power. And the house started, caught fire like 5 or 10 minutes later. But nobody was home. There's nothing we could do. But these things, the wind creates problems on the utility grid, whether it's for winter storms or hurricanes, and then obviously wildfires are just a whole nother thing that we're obviously very familiar with.
Yeah, I was watching your the app, in this last winter storm, and I didn't go to the Eversource's utility up here, and I wasn't watching their outage map. I was actually looking just at your app, right, to see if I was losing power and if I needed to speed home or not. Because it's wintertime, you don't want to lose heat either. So, get the generator going if need be. But it was, it was a great tool to use.
Yeah.
So.
No, we appreciate that. Yeah, it's super important. In fact, we added like a notification for frozen pipes. Obviously, you already hit on it, but a lot of people don't realize, right? You lose power, you lose heat. If you're not home, you're at risk of frozen pipes, and that's a terrible situation to return to. Devastating.
And the fire protection industry, frozen pipes is a big issue. So I think there's going to be some people listening to this that are like, oh wow, well can we do this and this anyway? It'll get people's brains moving a little bit on some potential ideas for it too.
Yeah. So the other thing, and I'll just touch on this before we get toward the end, but the LA fires obviously were just a huge, devastating event from a little over a year ago. I'm going to show you some data here from the Eaton Canyon fire, which devastated Altadena, the town just at the foothills of the mountains. And I'll show you just an example here of data from one Ting sensor in Altadena on the left. A reporter found this image. This is not our image. This is just an image from a camera image from a gas station. This is just a light post, so ignore the light post in the parking lot. But off in the distance, in the gold square, is the transmission towers that may. Again, I think the investigation is still underway, so I don't want to say what caused the fire. But in the distance is the transmission towers. And you sync the Ting data to the camera, and what you're seeing is there's a gigantic grid fault that occurs. At 6:10:59, and then a second one at 6:11:02, and the fire is burning there. So that flash, that arc flash that occurred, coincides with the measurements that we take on the Ting sensor network, and that's just one Ting sensor. But I'll just show you one more thing here. Is if you just look at the entire fleet of Ting sensors in the Western grid. What we've done in this analysis here is just normalize the voltage. So if the voltage is normal, it's blue. And each blue dot there's, I think, 250,000 Tings out there or something. That fault, when it occurred, the one that you saw on the camera, we just looked at one sensor, that data, that fault was sensed by every single Ting sensor in the Western U.S. So, that's how sensitive the sensors are. And that's how we know that this was a transmission fault, by the way. So, transmission, they're the big, giant, hundreds of thousands of volts lines. And they're connected city to city. So when something bad happens on one of those, every Ting sensor in a very broad geographic area sees that event. But what we want to do is help utilities, to understand when the grid is challenged, right? So when you look at kind of those faults that were occurring in LA, they really started about 4 o'clock in the morning. As soon as the wind picked up, the Ting sensor network is almost a direct measurement of the impact of the wind on the grid. So wind is not a fan. The grid is not a fan of the wind, right? I mean, it's blowing the wires. There's tree limbs touching. There's bad things happen, and we see every one of those faults essentially, and hopefully we can provide data to the utilities to help understand where they have challenges, maybe make decisions on turning off power before it can spark an ignition and things like that. So that's kind of what we're focused on from a company perspective is just leveraging the technology that we're fortunate to have to protect individual homeowners, but then as we go, continue to help communities and on grid-related matters.
Yeah, and I like your method of going upstream, right? You're B2C, you're going to the consumer, and you're helping them out, but you're working with the insurance companies and now the utilities, and I think those, they could just be pushed down from there. They want the data the most, so I think you made it easier for the consumer, and then obviously beneficial for the insurance and utility.
Yeah. So it's, I think everybody, hopefully it's, it's just it's a great application of AI for good. And we're pleased. And we want to, you're the community that you have in your podcast community here. I mean, there's a lot of people that are in the fire safety, fire protection, and to the extent we can, we want to partner with people and entities in this ecosystem to, if you can benefit from Ting or want to work with us in some way, let's get in touch. And obviously, if you don't have Ting, get Ting. And for your own home, it should be free. Most, check with your insurance carrier, because a lot of times you can get it for absolutely free. They pay not only for the hardware, they pay for the service. They pay for it for years and years. So because they know it prevents fires. So, we do sell, you can buy it on tingfire.com for sure if you can't get it from your insurance carrier. And it's $99 for the first year and then $49 a year. But that includes the $1,000 credit too, right?
Oh, wow.
That's everything. So
that's amazing.
We pay $1,000 if we find a problem in your home.
Wow.
If we need to. So that's kind of what we're up to.
No, this is great. I'm glad to finally get you on here and get the message out there. I've been a big fan of this product, and there's been a struggle in the fire protection community, at least in the more and more on the commercial side, is like getting more IoT out there, right? And it's in the codes, it's accepted, but it's like it's being slow, and a lot of it has to do with the AHJ and authority having jurisdiction, which usually goes to the fire marshal, but another AHJ is the insurance provider. So you've kind of hooked into the insurance provider, which is then going to, I think, help push this and just get better data for us as a...
Yeah, to me, obviously, I'm a huge fan of sensor networks. I just think the power of a sensor network and the technology and the AI today can really help. We want to, we're not really in commercial space today, but we will be. There's no, the technology has applications in commercial sector. We just haven't had time, to focus on that thing yet. But, yeah, this has been great, Drew.
Yeah, appreciate you coming on.
Yeah, no, appreciate you. You're doing great stuff. And, anything we can do to help you and the community, we're happy to do so.
Yeah, let's check in again soon. And thanks again for stopping on. It's been episode 92 of the Fire Protection Podcast, powered by InspectPoint. Want to thank Bob Marshall again, coming on from Whisker Labs /Ting to talk about everything about IoT and fire safety and what they're doing to really give a lot of great data to the fire protection community, but also the electrical community and the HJs as far as insurance providers go. So really cool episode, and hope to do more of these here in the future. Thanks again for listening.